everyone! Today we're going to be talking about exothermic and endothermic reactions and how to calculate them. I know because you love math so much. That's all we're going to be doing today. I'm not going to burden you with a bunch of vocabulary words or anything like that. Really quick though, if you didn't do so well last 9 weeks, the third 9 weeks, please just send me a message so we can try to figure out how you're going to pass the whole semester and how you can save the semester. So without further ado, here we go. A thermochemical equation is a balanced stoichiometric chemical equation that includes the enthalpy change, represented by the symbol triangle and the letter H. So enthalpy change is triangle H. Enthalpy is basically the transfer of heat in this case. It's usually the transfer of energy, and in this case we're using heat, so H for heat. Just remember that and you will be fine. Enthalpy is the transfer of energy in a reaction, so the transfer of heat. So in a chemical equation, let's say you're trying to find the enthalpy change. You're just basically trying to find if the heat went inside the reaction or outside, if there's some energy was liberated. If the heat from the products is lesser than the heat from the reactants, then that makes delta, the triangle, that makes enthalpy change negative. That reaction is going to be exothermic, so that means that energy was released. If on the other hand, if the heat from the products is greater than the heat of the reactants, then enthalpy change, triangle H, is going to be greater. It's going to be a positive number, so that means that it is going to be endothermic. Okay, it's super easy. Basically, all you have to do is subtract the number from the products, which is on the right side, and the number from the reactants, which is on the left side. All you have to remember is that if it's negative, it's exit, it's outside, it's going outside. So negative, out. Okay, like your it's negative, it's toxic in your life, just let it out. Okay, so negative, out, it's exothermic. Positive, it's endothermic, so you're letting it in. Okay, so positive is in, negative is out. That's all you have to remember. Okay, and I'll show you how to do that right now. The first example says, reacting 2 moles of solid sodium with 2 moles of water to produce 2 moles of aqueous sodium hydroxide and 1 mole of hydrogen gas will release 367 kilojoules of energy. So the way you're going to write it down, just write the whole thing as you normally would. So it would be 2 moles, so the number 2 of sodium, Na, plus 2 moles of water, so it's 2 H2O, yields 2, or produce, so you're going to put the arrow, 2 moles of aqueous sodium hydroxide, so NaOH, 2 NaOH, plus 1 mole of hydrogen, so H2, and it says it will release 367 kilojoules. So one thing you can do is just put the 367. Since it's going to be released, you're going to put it on the right hand side. So just put that one there. On the right hand side, just next to the products. So on the right side of the arrow. So you're going to put plus 367 kilojoules. That's it. The other one says 184.6 kilojoules of energy is needed to produce 1 mole of hydrogen gas and 1 mole of chlorine gas from 2 moles of hydrogen chloride gas. So you're going to put 2 HCl, because that one is the things that you need, plus the 184.6 kilojoules of energy, yields 2, it says to produce 1 mole of hydrogen gas, so H2, and 1 mole of chlorine gas, so Cl2, and that's it. So you're just going to put the number, if it's positive or negative. You're going to put the number either on the left-hand side or on the right-hand side, depending on if it's been produced or if it's needed in the equation to be able to get the reaction going. You can either put it on the left-hand side if it is needed for the reaction, or on the right-hand side if you actually produced that energy. Sometimes they're going to give you the number or the heat of formation for each one of either the reactants or the products. If they do give you the number and they want you to calculate the change in enthalpy, all you have to do is subtract the products from the reactants. So let's say if we want the heat of formation of C2H6, all we're going to do is look at the table that they usually give to us and look at the numbers, and then when we create our equation, we just put the heat of formation for each one of them and subtract them. let's say you want to solve the change of enthalpy for a chemical equation, like this example right here. We have what is the change in enthalpy for the process used to make lime, which is calcium oxide, which is CaO. So Ca for calcium and O for oxide. So let's say we have calcium carbonate, CaO3, and then it decomposes into calcium oxide, which is CaO, plus carbon dioxide, which is CO2. So we have our equation right there. According to the table, calcium carbonate, it has a heat of formation of negative 1,207.6 kilojoules per mole. So we are going to put that number below. And then we have calcium oxide on this side, and that one has a heat of formation of negative 634.9. Okay, so we're going to put it right below calcium oxide, and it's negative. And then we have carbon dioxide, and that one has a heat of formation of negative 393.5. So the first thing I'm going to do is I'm going to add both numbers from the right hand side from the products. And once I get that number, then what I'm going to do, I'm going to get that number and subtract the number from the reactant, which is calcium carbonate. I'm going to subtract negative 1,207.6, and that is going to be my change in enthalpy. So you see, you just have to put the numbers in its place and get the number from the products and subtract the number from the reactants, and that's it. It's just subtracting, and that's it. So let's see this other problem right here. What is the heat of formation, or what is the enthalpy change for the combustion of C4H10? Then we're going to look at our enthalpy table. So we have C4H10, and the heat of formation is going to be negative 30 kilojoules, so I'm going to put it there. The heat of formation for oxygen is 0, because it's a pure element, and it's going to be 0, so it's not going to be formed with anything, so it's just going to be 0. The thing is, when it's an element by itself, it's on the universe, so it's not forming, so it doesn't need heat of formation because it's not forming, it's just there. So heat of formation for oxygen in this case is going to be 0, nada. It's going to yield to water, and the heat of formation for water is negative 241.82 kilojoules per mole. And then we have carbon dioxide, which the heat of formation is negative 393.5 kilojoules per mole. So this is per mole. So as we can see, we have 2 moles of C4H10. So I'm going to multiply the 2 moles times the heat of formation. I'm going to multiply the 13 moles of oxygen times the heat of formation. I'm going to multiply the 10 moles of water times the heat of formation. And I'm going to multiply the 8 moles of carbon dioxide times the heat of formation. Once I get all those numbers, I add them up on both sides of the arrow, and once I get those numbers, then I'm going to subtract them. So this is the hardest it's going to get, okay? So that is it for today. So as you can see, it's basically just subtracting, and that's it. That's all the math you have to do. adding and subtracting, and that's it. If you have any questions, don't hesitate to ask me through Schoology. But if you want me to show you like an example or something like that, or work out a problem, just let me know so we can set up a conference, so I can help you out, okay? So thank you so much, guys. Wash your hands, stay safe, wear face masks, protect yourself. Be amazing. See you later. Bye.